Good morning, Griffin.
Well, it's really nice.
All right,
Good
so
night.
we're gonna go over the homework first. Here we go. These are questions from homework for 6-3. All right, and I believe the instructions on 15 are to find the average value of the function, right?
Correct.
And the formula for the average value of a function, that means, right, we're gonna sum up all the y values and divide by something, right? So the formula for that is 1 over b minus a times the integral from a to b of f of x dx. This is the average value of a function. All right, now, we're going over the interval from -4 to 2, so this is a and this is b, right? So then our average value of our function is going to be 1 over 2 minus a minus 4 times the integral from -4 to 2 of f of x dx. Now, obviously, it's really simple to see that this is 1/6 in front. And the difficult part of this, perhaps, is realizing or recognizing, what does this mean? This means the area under f of x from, right, so this is the area under f of x from -4 to 2. So, do we have a way of calculating that by looking at the picture? We do, don't we? We can say this, and we can say that's a triangle, and we know that that area is going to be 1/2 its base, and the base is from -4 to 2, which is 6, times 6 times its height, which is 3. And so the 6's cancel out, and the average height of this function is 3/2. And does it look like, if you look at the sketch, that between -4 and 2, the average height would be 3/2, which is 1/2. So that's how you find the average value of a function. All right. Moving right on. Number 17, we have to do the same thing. Average value of a function. All right, so this is the sine function from 0 to 2 pi. So I'm just going to, draw a representative of that. Oops, that's not helpful. Is it going to have 0 right in the middle? This is pi and this is 2 pi. And this is t and this is f of t. So average value of a function, let's do that. Average value, what's the formula? Remind ourselves, 1 over times integral from well, a to b. I'm doing the generic function so that we can just plug in what we know, right? Now, looking at this, what do you suppose the average value is? 0. Right. Does it make sense to you that it would be 0? Yes. You have the same amount of y values above as you do below, and so that's going to average out to be 0. Well, let's see if the formula makes that true. So this is going to be 1 over b minus a. Well, b is 2 pi, a is 0, so that's just 1 over 2 pi, times the integral from 0 to 2 pi of sine of t dt. But graphically, what does this integral represent? The area under sine of t from, I'm just going to say 0 to 2 pi. But what do we know about that? What kind of area is this? Positive. What kind of area is this? Negative, and they're the same. So they cancel each other out. So this turns out to be 1 over 2 pi times 0, which is 0. So we know that the average value of the function is 0. Make sense? I'm so glad. So it's got that scary smile on it.
I don't have a scary smile.
Yeah, it's like a round smile. There it is. I was going to take a picture of it. All right, here we go. 31. Can you help me with the instructions on 31?
Average value of the function, and then some
We want the average value of the function?
Yes.
Average value of f of x over 0 to pi. All right, well, let's refresh our memory. What's the average value formula? Everybody all at once now. That's hilarious. It's not like we're on video or anything. You can't time uniform. All right, so this should be easy enough to say that this is 1 over pi, right? Times the integral from 0 to pi of sine of x dx. Now, what they want us to do is use the fundamental theorem of calculus, which is we're going to take the antiderivative of sine x. So sine x is somebody's derivative. Good. So this is equal to 1 over pi times negative cosine of x evaluated between 0 and pi. And so what we do, we say, we put 1 over pi out here, and then we're going to put cosine of, negative cosine of pi, right, minus negative cosine of 0. So this will be 1 over pi times, well, what is cosine of pi? It is negative 1 times, so it's 1 minus, how about you?
Negative 1.
Minus, this is a 1, negative 1,
So plus 1.
Plus 1, yes.
yes, right? So that turns out to be
2.
2 over pi is the average value. Okay? And that was using antiderivatives. 33, doing the same thing? All right, so the average value formula is equal to 1 over b minus a times the integral from a to b of f of x dx. You have it memorized yet?
Yep.
I memorized last week.
Does Griffin? Yes, I guess that's a good question. All right, so this is going to be 1 over pi over 4, right, minus 0, which is pi over 4. And then from 0 to pi over 4 of secant squared x dx. And 1 over pi over 4 is really equivalent to 4 over pi. You guys are so good. Morning times the antiderivative of, yeah, tangent. Evaluated between 0 and pi over 4. So this is going to be 4 over pi times the tangent of pi over 4 minus the tangent of 0. And due to that wonderful, amazing pre-cal teacher you have, you know what the tangent of pi over 4 is, right? That's 1. So that's pi over 4 over pi times. Oh, sure. Got it? Okay, let's go on. Are you lost?
No, like, no, what just happened right there, I'm not lost.
Oh, that's good.
But you're probably lost.
I want to try and get them. Okay, next one.
I'm sorry.
Average value, any questions? 35. The average value is equal to 1 over b minus a times the integral from a to b of f of x dx. Now, I'm doing this repeatedly so that we don't forget. That's right. Probably. It's very important.
It's fundamental.
Overrated.
So this is 1 over 2 minus a minus 1 times the integral from negative 1 to 2 of 3x squared plus 2x dx. This is 1/3. Whose derivative is 3x squared? X cubed. Good. So this is x cubed plus x squared evaluated between -1 and 2. All right, so we're gonna do 1/3 out here, and we're gonna plug in the 2, and we get 8 plus 4, which is 12, minus, a -1, you okay?
Yes, just be more.
So this is -1,
Plus one, which is 0.
which is 0, okay. So this is a 4, is the average value. Oops. Okay. What's the matter, Robert? I see consternation.
Oh, no, I was just trying to follow it. I think got it.
What did we do? We said 1 over b minus a, which is easy, right? And then we did the integral of 3x squared plus 2x. That's a function. And whose derivative is this?
Of x cubed minus, or x cubed plus x
Do you
squared.
see that?
Yeah.
And then what we do is use the fundamental theorem of calculus and evaluate it at 2 and then evaluate it at -1 and subtract it. All right, 49. What is the average value of, they want you to use your calculator for this. Woo-hoo! Okay, so, let's do that. This is an all-service video. Okay, we're gonna open this up. Somebody got a calculator really quickly that I can?
Here you go.
No, I got mine. Sorry, I should have this already set up, shouldn't I? But
No, it's okay.
button to focus. Okay, so I'm turning on my calculator, and the average value formula is 1 over b minus a. So what is 1 over b minus a in this case? 4? 1, so it's going to be 1 divided by 4 times the integral. So we get to the integral by F3 int, or we could do second 7, and then my function is, oh, I can read it from here. Cosine, right? So it's cosine, oops, not z, second cosine of x, comma x from 1, comma 5, oops, not 8, 5, close parentheses, and I'm in rads, do you notice? Calc is rad, and then I'm going to find the answer to be -0.
I got sine of 5 minus sine of
Okay,
You have to press the button.
you have to press the diamond because we want a decimal answer, right?
How'd you get the
How'd I get the,
square root 2? Or is that from the last one?
oh, no, that was from BC calculus, sorry. I don't like,
You just hit, you hit diamond enter first.
yes. I'm gonna get a different screenshot here because that's so dark.
Bless you.
God bless you, yes. It's still dark, but oh well, there it is. Okay, number 50. The average value of the function f on the interval a to b is 10. So what does that mean? The average value, what's the formula? Let's do it. 1 over b minus a times the integral from f of x dx is equal to 10 is what you're saying, right? then the integral equals, we're just solving for this, right? So what are we gonna do? We're gonna say the integral from a to b of f of x dx is equal to 10 times what? We multiply both sides by b minus a. So this is 10b minus 10a. Right, so that's all we're doing is we're multiplying both sides by b minus a. To get that. All right. Quick quiz. If the integral from a to b is equal to, okay, can we bust this integral up? Yeah. Can we say the integral from a to b of f of x plus 3 dx is equal to what? The integral from a to b of f of x dx plus, this is the additivity property, right? Or the sum property, where I can say this is 3 from a to b. You remember we did plus or minus with f of x's? Do we know what this one is? They told us, right? So we can say that that's equal to a plus 2b, and now we can find the antiderivative of this. What's the antiderivative of 3? 3x, right? So this is 3x evaluated between a to b. So this would be a plus 2b plus, I plug b in, I get 3b minus 3a, and we can simplify, and that's what, negative 2a plus 5b.
Where do we get the minus 3a?
When we do the evaluate the fundamental theorem of calculus, what we do is we plug f of b minus f of a. And so then I can rewrite this, right? So it's 5b minus 2a, so that's choice D. All right. This is a Riemann sum approximation, meaning I'm adding up a bunch of rectangles, right? So what is this typically in front? Yeah, that's delta x. So delta x equals b minus a over n. So what's n here? N is 20. What's b minus a? 1. So the change in b minus a is 1. No, I'm saying the difference between b and a is 1. So that means my limits of integration have to go from 0 to 1. Do you see that? Because this would be my b is my upper limit of integration and a is my lower, right? So are there any we can eliminate? Yes, eliminate that one because that one goes from 0 to 20, okay? Now, what do you suppose f of x is? Yes, f of x is, she says root x. She's right. Why? Because what do we plug in our formula? You usually say f of x, or delta x times what? F of x. Well, if we're doing, we're going to put, this would be my first rectangle, this would be my second rectangle, this would be my third, this would be my 20th rectangle, right? So my integral I'm going to suggest to you is the integral from 0 to 1 of f of x dx. But what Patricia just said was f of x is root x dx. Because what are we putting in here? This is delta x. And if you were to graph this function, whatever it looks like from 0 to 1, Now there's my classic, function. And I'm putting it in what kind of increments here? 1/20th, right? So there's 20 of them in here. So I'm going to put in 1/20th, I'm going to put in 2/20ths, I'm going to put in 3/20ths, right? If I'm doing RAM. So do you see how I'm putting in 1/20th, 2/20ths, 3/20ths, and then I'm going to put in 1, which is the very last one? So this is RAM.
Oh, got it.
You see, it's hard to see, I know, really it's hard to see, but that's going to be B. Everybody see that it's B? So sometimes it helps me if I draw a little picture like this, because I'm a very visual person, and I suspect some of you guys are too. Does that help? But noticing right away that this 1/20 is delta x is a big deal, because then that helps you with the limits of integration being with a difference of 1. And then your subdivisions being 20. And then you could probably go to the picture right away.
Wait, can you show one up here?
Sure. So that's just RAM. Or the square root of x with 20 subdivisions. From 0 to 1. Approximating that interval. That's a hard one. I would say that's a hard one.
I agree. Yes. Definitely.
All right, next one, number 4. Let this be our function. F of x, f double prime of x equals 6x plus 12. We want to find f of x. So I have to do the antiderivative to find f prime, right? So how do I find f prime? Going backwards, right? So whose derivative is this?
3x.
Good, this is 3x squared plus 12x plus c, some constant that we could have taken the derivative of, right? Now we need to find c. Well, they told us some information. They said the graph is tangent to the line 4x minus y equals 5. What are they telling us there? The slope. So the slope is going to be, let's solve for y here. Let me move the y over and get 4x minus 5, right, equals y if I move the y over to the right. So what's the slope? The slope is 4 when x is, they're telling us the slope at 0, -5. When x is 0, do you agree? That's what they're telling us? So I can say then, my f prime is 4 when x is 0. So c is equal to 4. Can you see that? Ha ha ha. So f prime of x is equal to 3x squared plus 12x plus 4. So that's one step. Now we have to find f of x. What's the antiderivative of 3x squared? X cubed, good. Plus?
2x.
Well, I'm going to raise it to square and then divide by 2, so it's 6x squared. Yes. Plus 6x squared plus 4x plus c. C, but I know a point. Using what point? 0, -5, right? Because it's passing through that point. So what is c in this case? If I put -5 equals 0 cubed plus 6 times 0 squared plus 4 times 0 plus c. C is nothing but -5. So f of x is equal to x cubed plus 6x squared plus 4x plus c. So that's, I think the answer is, oh, -5, sorry, -5. So that's the answer to part A. Let's work for part A. Part B says find the average value of f of x from -1 to 1. Well, average value. Good, 1 over b minus a. Whoops, I should write it down right. Average is equal to 1 over b minus a times the integral from a to b of f of x dx. So we know it's equal to 1 over, and this is over -1 to 1. So this is 1 over 1 minus a minus 1. 1/2 from -1 to 1 of our function here, which is x cubed plus 6x squared plus 4x minus 5 dx. Can we do the antiderivative of that? Sure. Raise the power and divide by it, so x to the 4th over. X to the 4th over 4 plus,
Plus 3x. Wait, or well, I guess it'd be 6x to the 4th.
racist,
2x cubed.
yeah, okay, I like that better. 2x cubed, because you're raising this 1 and dividing by that same exponent, okay, plus
2x squared.
2x squared, good. Plus, minus 5x. Now, why don't I need the cupcake here? Because the cupcake would subtract out, wouldn't it?
Of course, Mr. Moore.
Obviously.
All right, so I'm gonna plug in 1, what do we get? 1/4 plus 2 minus 5 minus 1/4 minus 2, right? Plus 2 plus 5. Okay, well, let's see what happens here. These, these two cancel, right?
Wait, good question.
Yeah.
Does the first one have to be, or does the second set of numbers have to be led by like another negative?
Yes, yes, because what is the fundamental theorem of calculus state? It states this is equal to the antiderivative evaluated at B minus the antiderivative evaluated at A.
But since A also has a negative, you put another negative there. You already have a minus. Well, on the next one down. See how you have 1/4 plus 2 minus 5. Then you have minus all that. You put a negative in front of that as well.
This here?
Do you make that a positive?
No.
Because it's minus in the equation and it's -1.
This right here is f of 1. This right here is f of -1.
I know, I got you, but like, see in the equation how it has an f, like f of 1 minus, you have a minus and then it's also f of -1. So would you not make that positive? It's be negative.
You're saying take a negative out of it?
Well, I thought,
You saying like,
I don't know.
Shooting factor in.
I know, but doesn't the negative, isn't there negative or a minus in the equation already? We
Where?
have two.
Where is the minus in
F
this
of b is
equation?
minus f of a, or in the
This equation has no minuses except for here,
I'm
right?
talking about the theorem.
Right?
Yeah, f of b minus f of a.
Okay, this is f of b
Yeah,
minus
Mhm.
f of a.
but since f of a is f of a negative number, does that not?
But she already
Yeah,
plugged
you
it,
just
she already
plugged
plugged it negative
Yeah,
1.
it's negative x.
Because when you
Oh, I
like,
got you.
when you like,
-1
When's the first?
Negative
oh,
one
it's
and the
x to
four.
the fourth.
What I'm
I got
doing,
you.
what I'm doing is I'm
I
plugging
just
negative
did
1
negative.
in here.
Yeah. But since the first one is like x to it, even, or an even x. Yeah, that's fine.
Okay. All right. Okay, so the next cancel, right?
Sorry.
No, it's fine, it's fine. I misunderstood what, you heard what he was saying.
Yes.
I misunderstood that. I was trying to understand. Okay, so this goes away, that goes to 0, right? The 1/4 cancel. And then this is 4 minus 5, -1, -4 minus 5, -9, over 2. I'm sorry,
Negative four.
Try again, this is 4 minus 5, -1, -1 minus 5, -6. Okay, I can add, okay, so this is -6 halves equals -3, I hope that's the answer. After
It is.
all of that.
Well, it's on the board, so now it's official.
Well, yeah, but I can officially.
If it's wrong, we'll gotta move on.
Right. Okay, so,
Leave the number, so we're not gonna answer.
so that's, the homework.